وأثر الاقتصادي وطرق التشخيص والعلاج في الطيور، مشاريع الدواجن. وهذا طبعا يأتي من انطلاقا من حرص الوزارة بالتعاون مع القطاع الخاص، وخاصة مع شركة برينجر اندلهايم، لتعزيز التعاون بين الوزارة، وزارة البيئة والمياه والزراعة، والقطاع الخاص لنشر الثقافة وتبادل المعلومات ونشر الفائدة قدر المستطاع. ومشكورة شركة برينجر اندلهايم في التعاون مع وكيلها شركة الاقتصادي، مشكورة على تعاونها معنا وإتاحة الفرصة في عن طريق الاجتماع الافتراضي. وإن شاء الله نتطلع المزيد من التعاون بين الوزارة وبين الشركة، وإن شاء الله أن ورشة العمل تكون مثمرة يعني ونستفيد جميعا
بإذن الله.
إن شاء الله إن شاء الله إن شاء الله دكتور عمر.
إن شاء الله.
تحياتنا لجميع الزملاء ودكتور علي الدويرج وجميع الإخوة الزملاء في وزارة الزراعة، اللي طبعا دائما بنحظى بالدعم منهم، مش في المرة دي بس، من 30 سنة عدت الحمد لله وإحنا بنخدم في المملكة كقصيبي، والحمد لله انضمام برينجر اندلهايم لينا كمان زاد الأمر أكثر خدمة إن شاء الله لبلدنا السعودية ولصناعة الدواجن. فشكرا لكم على الاهتمام الشديد يا دكتور عمر، مع تحياتي لكل العاملين في الزراعة من وزير الزراعة إلى أبسط عامل في الزراعة.
الله يعطيك العافية. شكرا يا دكتور. الصراحة دكتور علي الدويرج كان وده انه يكون حاضر، بس انه عنده ارتباطات اخرى، كذلك دكتور علي الجاسم، فيعني ولا كان ودهم انكم موجودين معنا
ومع بورينجر ومع لخدمة الوطن ان شاء الله.
ان شاء الله.
طيب حبيبي، شكرا لكم.
العفو.
اوكي مستر دكتور ستيفان. Dr. Francisco, we will come to join us with Ministry of Agriculture. It's okay يعني for good inshallah meeting, and I don't need to speak a lot of English. It's okay. Welcome to you.
Yeah, perfect, Dr. Safwat. Thank you.
Yes.
Yes, Barry, please.
Hi there. How are you doing? First of all, sorry, I just pushed it. First of all, I'd like to thank Dr. Sami and Dr. Omer of MIWA for hosting this on behalf of MIWA and Boehringer Ingelheim to discuss Marek's disease and the impact that this has on the industry. We have a packed agenda today, which I have just lost. Apologies. Sorry, I pushed the wrong button. We have Dr. Stefan Lemiere, who will be talking about Marek's disease epidemiology and impact, and then followed immediately by Dr. Mohammed Helmi, who will give an Arabic summary. We will have a short break so that we can then follow up with Dr. Francesco Prandini, and he will be focusing on Marek's disease diagnosis and control, and that will be immediately followed by Dr. Hosam Galal in an Arabic summary again for everybody to have a good grasp of this. And then following that, we will have a question and answer session, which everybody will be participating in, and it's the opportunity to ask all the awkward questions regarding Marek's disease. And then we will have closing with Dr. Ali, who's the Director General of MIWA, Veterinary Health and Monitoring.
Dr. Omar will be here because he will be leading the session today. Dr. Omar.
Okay.
Inshallah.
Bismillah. Good. So we are all okay. We can start.
Oh, have we not started yet? Sorry, that's good. Is that
super? Dr. Stefan, floor is yours.
Okay, you You cannot hear me, but you see me. You cannot hear
Yes.
me. Thank you very much, and thank you, by the way, for invitation. The idea really is to review where we are with the Mark's disease. So here to be, you can say, a global overview. And we also check on some of the more specific highlights in Saudi Arabia, in the surrounding countries. The idea really again is to make sure that really we address the point that we understand the reason why Mark's disease is still a challenge for the poultry industry. That will be more or less what we'll talk about. And the second major topic is about, I would say, what will be the future, how the virus is evolving, and what will be the future of Mark's disease. So if you permit me, I'm going to start with my slides and the presentation. That should work like that. Then you see my screen. I think it should be okay. So again, thank you very much, and for this opportunity to give again the point of view of a service vet, and also because my background is also about virology, microbiology, by experience and by training when I was at the university. So for that reason, I'm going to give you what is really at stake with Mark's disease and what really we should expect today. Let's start with the economic impact worldwide, because Mark's disease is probably sometimes underestimated, or is not, I would say, a very common topic. And for that reason, we really need to start to check what is really the impact on the industry worldwide. So the impact on the industry is huge for one particular topic, that is the unpredictability, that means unpredictable outbreaks. There are many reasons for that. It's maybe related to virus circulation, variants of the viruses, but as well sometimes some of the, I would say, troubles that may occur during the vaccination process, mixing and handling particularly. We know that Mark's disease is, let's say, one of the causes of tumor disease of chickens, of poultry, generally speaking, but we know that it's also an immunosuppressive agent. So that one is very important and may somehow impact negatively the performances. And especially it could be is not really well studied, especially in a country where we don't raise the borders at a very old age. But even in borders, we may see some of the impact of the immunosuppression linked to Mark's disease virus circulation. We may see some increased condemn rates, and it could occur even in borders. And this is again something we've been monitoring in many countries. This is something well known, for example, in North America. Obviously, it can impact negatively the egg production. As long as we've got long-lived birds, such as layers, egg producers, may suffer from some of the Mark's cases. And it will really greatly affect the long-lived birds. And something to illustrate that could be, for example, in countries where we've got an increased lifespan for the broiler, also the meat-producing chickens, we cannot escape. We really need to vaccinate against Mark's disease, despite the fact that for these short-lived broilers, usually is not needed, and most of the countries don't do it. And worldwide, I think I can say the strong impact economically is something that could be evaluated has really huge losses that we here recorded that could say be something like big numbers, 1 to 2 billion in losses worldwide. So just to tell you that the Mark's disease is really a big deal, and something again, even if we really target and speak mostly on long-lived goods, is not only restricted to long-lived goods. This is not an academic presentation, so I'm not going to give you all the features of the Mark's disease clinics, but I'm more focusing here now on what is really at stake and important, I would say, for ourselves vets. It's an old story, an old disease, not new at all. First case reported beginning of the 20th century, and obviously later on. We've got tumor cases, malignant tumors in chicken skin. So spoke already on the borders, for example. It could be visceral tumors, liver, spleen, kidneys, fat, gonads, and so on. Nervous tissues, also legs, wings, ocular, respiratory, cellular, for example, infiltration of eyes. And overall, it will lead to mortality and condemns, especially in broiler chickens. So this is a very common topic. For example, in the USA, where you've got here individual shack of broiler carcasses on the line, and this is still today implemented. And this is the individual track or of skin tumors, mostly, but not exclusively. So this is very important, and this is the reason why, again, remember that accumulated litter is a risk factor for recirculation of Mark's disease viruses. And last but not the least, we've got egg drops and mortalities in layers. So that one is really a pain, because most of the time we see the outcome of, I would say, early infection, I would say, or vaccine failures, but we don't see immediately. We see it at the end of the reign period. That is really, economically speaking, a disaster, because you feed those pollets and you lose them when they become productive. That is really just terrible. Let's talk a little bit on how this lymphoproliferative syndrome occurs. And we've got here a target on the lymphocytes. I think this is very important to tell that we'll have a virus that is targeting first the T lymphocytes, later on we'll be targeting the B lymphocytes. And so in the second, second wave with the reactivation. And what is interesting to tell is that overall, we'll see, and this is also increasing by the variants, and we will get familiar during this presentation here with the classification on the way really we sort out the different virulence levels of Mark's disease. You recognize here, I can say, primary lymphoid organs, the bursa fibrosus, and the thymus here. So the thymus, so you see, is not easy to dissect, but you've got here, I can say, the full virus with the control, nothing happens, and this is a spleen here. So you see, according to the increase of virulence, virulent NDV, Mark's disease virus, very virulent DV plus, very virulent plus. We see, so the more virulent it becomes, the more it's targeting the primary lymphoid organs, such as the bursa fibrosus here, and the thymus, where the thymus atrophy. And this is here, and this is what we can see here by numbers. The percent of body weight in 8 days post-inoculation and 14 days post-inoculation with various strains. And the more virulent they become, and the more immunosuppressive they become. And we've got here, for example, the 648A, that is a VV plus strain. We've been working recently in our lab facilities for vaccine research with this strain. The North American one, by the way, they are all here North American. And I really can testify that this is really a high level of challenge and violence. So this is here, the Bursa weights. And obviously we've got from Dr. Kalmar exactly the same type of approach here with the thymus atrophy. And you can see here really that is becoming more and more drastic with more violence. And you've seen it illustrated by the picture before. So we really, that's one of the key features of this lymphoid tissue lymphocyte target of the virus. The lesions have become more severe. So that one again, just remember what we were considering. I can say starting from the virulent, very virulent, very virulent plus, and more associated to what we've seen from the beginning. I mean, mostly the polyneuritis. I mean, you can say the nerves, the long nerve tumors. We've seen more and more development of visceral lymphoma. Just look at the very beginning, it was not really yet described. So tumors such as the liver, liver tumor, the proventriculars, the intestine, the spleen, and so on. And this is really important to notice here. Immunosuppression have been from the beginning, really, I state here, one of the big deals. And remember, mostly checking on primary lymphoid tissues, organs, such as the bursa fabricis and the thymus. We got more and more occurring now. So these clinical forms of disease, such as the transient paralysis, and this is really very commonly described. And this is one of the key features of what we can see in field conditions, as well as some of the acute brain edema. So that one really has been really described in the most recent decades. And somehow we've got here the acute rash. This is really well described, for example, in North America as well, where some of the skin lesions out of the Mark's disease infection. So it was described here by Dr. Osterweider here with the famous scientist having worked on Mark's disease and the virulence factors of this virus. By the way, there's a kind of small digression here on the virulence factors. We got a lot of them. One of the most important piece of the genome of the virus is about what we call the MEK oncogene. It's a gene that is triggering the development of tumors, and this is really a key virulence factor that will lead to tumor formation. And this is a good way, really, when you do genotyping of virus strains. And we'll have Dr. Pandini speaking about diagnostic later on. And this is really a good way, again, to have an idea of what is going on and what could be, genetically speaking, the level of virulence of the Mark's disease virus you study. But what you must know is probably not enough really to help you classify into the B or the VV or the VV+. So that will give you an indication on this is an oncogenic virus. But this is fair enough with most of your conditions. I was telling you that it's not really a purely academic presentation, so but I cannot escape from some of the presentations here of some of the lesions. What you can see in the field, so upper side left here, obviously mortalities in breeders, and you've got here some of the clinical signs or lesions associated to that. Obviously, we may see this is typically here, in fact, and this is related to some of the nerve tumorization. Some of the visceral tumors here on the upper right side, and you've got here obviously gigantic spleen. We may see some of the spleen tumors that are always very, I would say, easy to see. The diagnostic will tell you, is it related to Mark's disease? Is it related to something else? So Dr. Pandini will talk about it. some of what I was explaining already. There could be some of the digestive tract tumors and generalized tumors, as you may see here in the layer. You can see some of the liver, some of the even the kidney, and so on, some of the visceral tumors, and obviously we open here some of the leg muscles dissected to check here on the sciatic nerve lesions, for example. It could be the brachial plexus, for example, a little bit upper. So also not shown here in these pictures, but remember, very important to check on, especially in younger birds, some of the dorsal or the thymus atrophies, obviously not at those ages. Let's talk about the viruses. And what we really can claim is the virus you find everywhere. Ubiquitous, we'll find it everywhere. All type of segments of production, all country, everywhere. It's highly resistant in the environment, especially in the dust, in the dermal cells. And it's a very clever virus because it's replicating in lymphocytes, I was telling you. So we find it mostly in some of the lymphoid tissues, but after we see in the tumor formation, a little bit everywhere, visceral nerves mostly. And it's very clever because it can replicate also in the feather pulp. I mean, it's a good way, a little bit like the seed for the plants, and just to spread and to contaminate the environment. And this is incredible because it's really a very effective way of transmission of the virus. So you can see here in the dermal cells, for example, because they're coming from the feathers, it's up to 6 weeks. The feathers are up to 4 weeks. And obviously, it's not related to, Saudi Arabia with the humidity, but it could be in some of the places. So it could be in some favorable environments, really even a higher time for resistance in the environment. It's destroyed by most of the virucid preparations. It could be iodine derivatives, so formaldehyde and others, all virucide products. The risk factor is an intensification of rotations, and the risk factor is mixing of ages on the same side. This is here a busy slide, but just to tell you that we can recover the dust from the chicken houses. And these are boiler houses, and the gray line here, as I can say here, the downtime with no chicken in the house. And it was a monitoring, a check of the dust. This is each column is a complex, and these are different houses with different risk factors. You can see that this house, for example, the same complex, is highly contaminated and is hard to control. And it may be due to a risk factor that could be close to that complex. I don't know, slaughterhouse, for example, and trucks loading poultry. That is a good way to contaminate the environment. Maybe something else. It could be an exhaust fan, for example, from another source and just spreading, I can say, and disseminate the virus. But it's hard really to get rid of it. And we can see that in the same complex, we may have less challenge, but sometimes growing challenge due to some of the risk factors. So it also could come from, I would say, the original, when you start the ring process. And interestingly, some of the monitoring we can see that here, for example, we could get rid of that contamination by, I would say, implementing cleaning disinfection procedures that were working well, for example, in those conditions. And we can see that in other conditions, in some of the complexes, we were punctually having high loads here. And by the way, after we see that in the whole complex, at least the 4 houses, because most of the time many houses, much more than 4, there was really, again, a good control of the environment. What is at stake here is important to tell that the virus is not quiet, and that's where, again, we'll see that there is a continuous evolution of these viruses, and especially we've got here some, I can say, high probabilities of mutations and somehow evolution. of the virus. The herpes virus, because we have to tell that it's a typical herpes virus, or the Marek's disease virus, is really showing some of the mutations and some changes that could lead some increase, for example, of violence. Again, this is exactly what we explain here. And by the way, there was a strategy here implemented to try to better control with some, use of some tools, such as, for example, it was in the US here, the Equator presentation here. HVT started for the control. Later on, HVT plus SV1 and here response. This is where we are today. So we are in between. We are not sure that we have really another step. But really the trend is obviously up. And we've got a continuum here of MDV partytypes. These are mostly here North American strains. And we can see here that the violence is really increasing by the time. By the way, it's very important because, again, I'm talking here on the vet side. What is really for vets at stake with Marek's disease? So it was here our colleague John Dunn from the USDA ARS lab in the USA. And John was just sending a questionnaire to all, I would say, a long list of vets worldwide. I was one of the recipients, by the way. And I replied for France. This is a country where I live, and it's my nationalities, but I presume I couldn't answer globally, even the global director. And it was very interesting. I'm going to show a couple of these, slides of the synthesis out of these questionnaires that prepared Dr. John Dunn. So here, what is a percent? What was the percent of questionnaire indicating frequent diagnostic of Marek's disease per country? So we can see, we just jump here to KSA, there it was considered as, I would say, rather quiet. At that time, almost 10 years ago, it was more a state here, remember, probably in Africa, where we were really facing huge problems of Marek's disease control. Again, percent of countries reporting increase or decrease of MD prevalence. And it was very interesting to see that the trend was really up everywhere, whatever the segment, crawlers, layers, or breeders. Again, the explanations for increase of Marek's disease incidence. And it was mostly here reported that it was other immunosuppressive disease or other causes. That means a lot of our colleagues worldwide consider that probably Marek's is not enough to explain everything, to no cases of immunosuppression. And there was some, especially for layers and breeders here, some reported, I would say, observations of what it was considered as higher valence MDV. Remember, the recipients of the questionnaire were vets, were not molecular biologists. Again, the countries reporting increased use of response. This is an interesting trend because if you use more response, that means you have less problem of Marek's that you want to tackle, or a topic that you want to address. And you can see here, most countries were reporting that increase of use of response in the vaccination programs. And same trend, if you got double vaccination or revaccination, either or layer or breeders, and this is the case in all the countries here, by the way, so whatever it's double vaccine dose, such as China, both double dose and revaccination, such as Europe, or revaccination mostly, like this could be Middle East, Africa, India. And this is a trend that explains that probably we've got more violent strain to control. And let's finish up with that one. I think the evidence of increase in virulence of Marek's disease viruses. Again, so I put some question marks in. See on the country, that is KSA. So the countries reporting increased virulence are numerous and were numerous and still the case today. I would say worldwide, or with some exceptions, it was mostly, I would say, Great Asia, some of the African countries. Remember, we were somehow, at that time, reporting high virulent strain of Marek's disease in that part of the world, and somehow some of the South America, and there were strains really trends up. So again, this is coming really from field observation. And this is, again, remember, vets who know what is Marek's disease, who know how to interpret what they see in the field. I mean, sort out what is really linked to vaccine failures, for example, and really unexplained Marek's cases with some of the tumor cases and how everything is correlated. And again, remember that if really we've got that, let's say, world map, we've got some of these countries where we've got reported increased violence. And this is really coming from the field observations and sorting out what is really related to vaccine failures to really what could be really interpreted as really increase in violence in especially of Marek's disease virus. A little bit of molecular, because we need to check on that. And I was telling you already, again, that one. Yes. So I was telling you already that the MEK-UNCU gene, this is that gene that is coding for that MEK protein that is transcripted. And this is really important for the what we call oncogenicity, the ability, the capability of the virus really to produce tumor, to make it very clear. And interestingly, here from this paper, so you can see here that we are not very far away from the Saudi Arabia. That what is interesting and important to notice is that again, we've got oncogenic viruses that are circulating. This is evidenced by molecular diagnostics. So that's the first part of it. What is also interesting from this paper, and I've been using that, I would say, for our vaccine checks, for our challenge virus collection and characterization, for example. This is very important for vaccine efficacy checks. Most of the studies so far have been done here with what we refer to here, clade North America. And I've got here, I would say, mostly related to Europe, Africa, and somehow Asia. We are all here in the same, I can say, in the same cluster here. Mostly, we don't see that much in terms of, I would say, violence factors. But this is interesting to cluster and to, to see how these viruses are related to each other. It looks like, again, that we've got some divergence between, I would say, the two types of virus populations. Again, this is not as strict as it looks on the slide here, because you know that chicks are traveling worldwide, I would say, from the Americas to the rest of the world, or the opposite is true. Maybe not from rest of the world to USA, that is the only exception probably, but from the USA worldwide in other parts of the world. So that way, again, is just to tell you that it's not really tight border. I mean, again, these are trends, and this is really interesting to refer to that. Again, I'm sorry, the next slide here is, again, and thank you, my dear colleagues, Sam and Naomi, just to update us and through my presentation on what is going on here in KSA. And this is rather recent paper, I would say. And the idea here is, again, referring here to the diversity of the MEK gene. Remember that this MEK gene will trigger some of the tumor cases, what we call tumor formation. And this is really important to tell that it has been studied in many countries, including here, Saudi Arabia. And here I'm going to show some of the key features. In fact, what is very important here is just to tell that, again, we have here something that is really of a concern. This is a conclusion here, that we may have some different factors that could somehow influence the phylogenetic diversity of the viruses. This is interesting to tell that, in fact, we are here in really the clinical picture that is mentioned here. I can say that is typical, again, of oncogenic virulent viruses. So this is very interesting, with maybe some of, I would say, some of the specific mutations that were really recorded and described in that paper. But overall, I would say, we've got here really a purely typical, I would say, Europe, Asia, Africa type of oncogenic virus. So this is really very important to tell. And again, remember that we may have again some of the input, because again we are talking about what is going on in a given region, in a series of bonds or complexes with different types of production. That could be also, remember that the shaders could be the layers or the breeders. Because they are long-lived birds, and probably they can really shed easily the virus. That's what I was showing you with the PCR checks of the environment. Remember that poultry byproduct or migratory birds could be also sources of I would say, virus transmission, and it could be a source of Marek's disease virus diversity. And I'm done with the presentation. So I think now we'll have Dr. Elmi preparing the Arabic summary. And thank you for your attention.
السلام عليكم جميعا. أنا محمد حلمي، مدير الدعم الفني ومدير التسويق لقطاع الدواجن بشركة برينجر في منطقة الشرق الأوسط. الحقيقة شكرا دكتور استبان على المحاضرة الجميلة دي، واسمحوا لي إن أنا أول لقاء برشح مع الوزارة في السعودية إن احنا نلقى حضراتكم، وخليني أعمل ملخص سريع لأهم النقاط اللي تم في محاضرة الدكتور استبان المنيب. طبعا الدكتور استبان بدأ محاضرته بأن هو ألقى الضوء على الخسائر الاقتصادية حول العالم لمرض المارك، اللي هي متمثلة فيما يقرب من حوالي 1 ل 2 بليون دولار أمريكي. والخسارة دي مش خسارة من الوفيات، هي بتشمل حالات التثبيط المناعي، زيادة نسب الإعدامات في المجازر، وانخفاض إنتاج البيض، بجانب طبعا الوفيات المتوقعة بفقدان البياض الأمهات أو التسمين. طبعا المرض كلنا زي ما حضراتكم عارفين كانت بداية ظهوره سنة 1907 على إيد دكتور جوزيف مارك، والمرض نسب ليه. كانت حالات أورام خبيثة تظهر على جلد الدجاج، الأجهزة الداخلية للجسم زي الكبد والطحال والقلب، بعض الأنسجة العصبية خصوصا نهايات الأطراف زي أعصاب والأجنحة والعين. وبرضه كان في حالات وفيات دمات موجودة بطيور اللاحم، وفيات ونزول في إنتاج البيض بدجاج البيض. طبعا التأثير الكبير لمرض المارك لا يقتصر على ظهور حالات أورام، ولكن أيضا بيمتد التأثير والتثبيط المناعي الموجود على الأجهزة الليمفاوية في جسم الطائر، اللي بتشمل البرسا والثايموس، المسؤولين عن إنتاج الأجسام المناعية في جسم الطائر. طبعا واضح حضراتكم ان على مدار السنوات تطورت الفكرات وتطورت الضراوه الخاصه بمرض المارك، وبالتالي تطورت الاعراض المختلفه منه تباينت ما بين اعراض مجرد اورام في الامعاء، لتثبيط مناعي، لشلل مؤقت، لبعض الالتهابات الجلديه الحاده على جسم الطائر. طبعا احنا شفنا بعض الصور التشريحيه للمرض، سواء في حالات رقاد بالطيور او في وجود اورام بالاعضاء الداخليه الطيور. فيروس المارك من الفيروسات اللي ليها قدره على التحمل الظروف البيئيه لوقت طويل جدا، ممكن بيعلق على الريش الخاص بالطيور لمده تصل الى 4 أسابيع. وطبعا ده بيزود في حاله التربيه المكثفه وجود اعمار متفاوته داخل المزرعه، بيزود من احتماليه انتقال. ويمكن في كيرف مهم جدا او مجموعه من الكيرفات عرضها دكتور ستيفان بتوضح ان استمرار فيروس المارك داخل المزرعه من دوره لدوره هو مرتبط بشكل كبير بكفاءه وجوده برنامج التطهير. لو في مشكله مارك مستمره ما بين دوره او دوره، فثبت ان عمليات التطهير وكفاءتها هي المسؤوله عن استمرار فيروس المارك الى فتره طويله. وطبعا قدره فيروس المارك على التحور لو استمر لفترات طويله في المزرعه هي عاليه جدا، والطائر قادر ان هو يخرج كميات كبيره او نسخ كبيره من الفيروس خلال يوم، وهو ده اللي ادى على مدار السنين ان يبقى في تحور وزياده في ضراوه المرض. طبعا تطور وضراوه المرض خلال السنين اللي فاتوا ان هو المرض تطور، لكن في نفس الوقت ما تطورتش اللقاحات غير لفتره بسيطه خلال 40 سنه الماضيه. ما تطورتش اللقاحات بما يتلائم مع تطور وظهور عترات شديده الضراوه من فيروس المارك. طبعا يمكن في مجموعه من الخرائط عرضها لنا بشكل كبير دكتور ستيفان بتوضح على مستوى العالم الدول اللي هي قامت بالابلاغ وعملت تسجيل لوجود وظهور عترات شديده الضراوه من المارك بشكل كبير جدا. وبالتالي في بعض الدول حصل تزامن او نقدر نقول ان الدول اللي زادت فيها ضراوه الفيروس بشكل كبير زاد معاها استخدام لقاح الريزدنت بشكل كبير جدا. وبرضه في بعض الدول ظهر ان في للتغلب على زياده الضراوه فيروس المارك باستخدام الريزدنت ظهر بعض المعاملات وعادات التحصين اللي ظهرت في المعامل، وهي استخدام جرعتين من لقاح الريزدنت، سواء دبل شوت او جرعتين في نفس التوقيت او جرعه يعقبها جرعه اخرى من لقاح الريزدنت. اخر نقطه طبعا دكتور ستيفان عرضها لنا هي بعض الدراسات اللي بتتكلم على التطورات الجينيه الخاصه بمرض المارك، وخصوصا في منطقه الشرق الاوسط. اول دراسه عرضها لنا دكتور ستيفان كانت هي دراسه من مصر، اثبتت بشكل كبير ان العترات شديده الضراوه اللي هي موجوده حاليا في منطقه الشرق الاوسط هي نفس العترات اللي تم تسجيلها في قاره اوروبا وفي قاره اسيا. فبالتالي احنا ما عندناش حاجه مختلفه عن اللي موجوده في العالم، احنا عندنا نفس السيركوليتنج او نفس الفيروس اللي موجود في الكون. والدراسه الثانيه واللي كانت مهمه جدا ومهمه لحضراتكم في المملكه، ودي كانت الدراسه الوحيده اللي تمت حوالي 4 أو 5 سنوات في المملكه على مرض المارك، وظهر ان العترات المعزوله في المملكه العربيه السعوديه هي فيها نفس التغيرات الجينيه اللي موجوده حول العالم زي ما قلنا في اوروبا واسيا. ويمكن الدراسه دي برغم انها كانت دراسه وحيده لكن اعطت توصيات وقت التوقيت ده بان هو لابد ان في احتماليات كبيره لوجود المرض، منها ان حاله الطيور المستورده الطيور المهاجره ودورها في انها بتعمل انتشاريه للعترات الجديده، وبالتالي لازم مراقبه برامج التحصين الحاليه وتطويرها وتعديلها بما يتناسب مع فيروسات المارك المنتشره حاليا داخل المملكه العربيه السعوديه. يمكن ده كان ملخص سريع لمحاضره الدكتور ستيفان، ويمكن انتقل دلوقتي للفقره القادمه مع الدكتور فرانشيسكو مارتيني. دكتور فرانشيسكو.
Can you hear me?
Yes, we are.
I think that we break first or we'll go direct.
Break first, yeah. For 10 minutes, break for 10 minutes.
5 minutes. 5 minutes.
5 minutes, okay. في استراحة لحضراتكم 5 دقايق وهنرجع مع الدكتور فرانشيسكو برانديني والمحاضرة بتاعتنا تشخيص وبرامج التحصين الخاصة بمرض المرض.
5 minutes break.
Dr. Francesco, yes,
Yeah.
you can start.
We can start?
Yes.
Okay. Okay, so can you hear me well? Can you hear me well?
Yes, yes, we do.
Yes,
Okay.
Francesco.
Okay, so first of all, I would like to thank the Ministry of the Environment, Water and Agriculture of the Kingdom of Saudi Arabia for the opportunity to organize this conference and share information with all poultry people in the kingdom. And also would like to thank my colleagues in Saudi Arabia and our distributor, Al-Ghazaibi. The topic of my presentation, as it was announced, is concerning Marek's disease, but more specifically, the control and first of all, a diagnosis. So here is the outline of my presentations, diagnosis, which will be split, in clinical signs and lesions, histopathology and detection of Marek's virus, and Marek's disease control based on biosecurity and vaccination with the current vaccines available. So as it was said by my colleague, Dr. Lemierre, before we see typical cases of Marek disease with neoplastic lesions, we can see the effect of the early replication of the virus causing immunosuppression with atrophy of lymphoid organs like busa fabaceus and thymus. So this is the very first effect of the virus because of the early cytolytic infection of Marek's disease virus. Another quite early sign of Marek's disease, still not neoplastic, is represented by what we call transient paralysis. This is caused by a kind of vasogenic brain edema, and it can be seen from time to time in flocks of broilers, especially after 5 weeks of age. And this is a transitory syndrome lasting 1 or 2 days. And from this point, broilers can recover, but probably later on within the flock, some of the chicken will start developing typical macroscopic lesions of Marek disease with tumors. So the most typical signs of Marek disease are related to the neoplastic effect of this virus. So we see stunting, we see depression, paleness, loss of condition of chickens in a flock. We can sometimes see nervous signs, especially spastic paralysis. We can record increase in mortality with tumors spread in different organs and tissues. And at the slaughterhouse, especially for broilers, an increasing level of the condemnation rate. So lesions can be present in different organs and tissues in the nerves, and this can cause paralysis. It can be in the proventriculus, in the spleen, in the liver, but especially in broilers, it is common to see lesions in the skin. We can also see lesions in the gonads, in kidneys, in the gut, in the heart, even in muscles, busa, and so on. Lesions in conditions where inspections are conducted according to specific regulations may lead to total condemnation of a carcass showing this type of signs. Now, practically speaking, if we are vets or agriculture engineers or technicians with a solid, sound experience in poultry pathology, it is not difficult to come to a diagnosis of Marek disease based on typical lesions. Okay, so we visit a flock, and in this flock we notice these type of lesions, macroscopic lesions with other signs. The first idea, the first conclusion is this is a case of Marek's disease. But in some cases, for commercial reasons, for epidemiological reasons, etc., it is important to confirm our diagnosis based on other tests, more specific tests, and one of these group of tests is histopathology. So histopathology can detect typical Marek's lesions, which can be of two main types. Type A are the neoplastic lesions due to infiltration of lymphocytes and plasma cells and macrophages, especially T helper lymphocytes or CD4 lymphocytes, which are the main neoplastic cells in case of Marek's, in different organs, in the spleen, in the skin, in the nerves, proventriculus, etc. But also Marek's virus can cause type B or let's say inflammatory lesions in the nerves. And these type of inflammatory lesions are absolutely very similar, if not identical to what we see in case of peripheral neuropathy, and I will explain later this point. Then another important point for confirmation of Marek's is based on detection of Marek's virus. So we see this DNA virus with specific characteristics and the capability to grow, especially in a certain type of cell cultures. So the first type of detection that was used for many years is the isolation of the virus from samples taken from chickens in a viremic phase or from tissues showing tumors in the chickens. Okay, this virus can grow in cell cultures, and then once we isolate the virus, it is possible to better characterize the virus by sequencing some of the key genes, as it was said before, MEC gene or other genes. The same virus, if it is interesting, it can be used for challenge studies to measure the protection provided by vaccination programs against this specific isolate. And another type of study that was mentioned by Dr. Lemierre is the pathotyping of the isolates that can classify viruses as mild, virulent, very virulent plus, and maybe one day VV++. This is a very sophisticated study that only a few labs can perform. It is also possible, as we said, use the PCR test for detection of the virus in tissues and maybe sequencing of some of these PCR products achieved from tissues with tumors or from feather follicles, from where we can detect the virus and quantify the amount of virus using a quantitative real-time PCR test. So one point I want to clarify is that detecting a virus in tissues of a chicken doesn't mean that we are facing a disease, because we know that the virus can be in a latent phase in chickens without causing any clinical signs. So detection is detection, and the disease is based on detection together with the clinical signs and lesions. The infection status of chickens can be different. We can have chickens latently infected with the virus, so we consider them as healthy chickens, and this is the case of the great majority of chickens in poultry production. But we can also have chickens with Marek's-induced tumors, so in that case we have sick chickens with the presence of the virus in big amounts and with lesions, mostly tumors. We also need to quantify the load of oncogenic virus in the tissues, and the real-time PCR test can help with this, because we are facing Marek's tumors only when the amount of virus is high in the tissues. one of the issues is also that we have three different serotypes or species of Mareks virus. So we have serotype 1, 2, and 3. So different PCR tests with specific primers can differentiate between the different serotypes. And another issue is that response or serotype vaccines, they are to some extent similar to oncogenic field viruses, or at least they belong to the same serotype. So PCR tests are necessary to differentiate field viruses from serotype 1 vaccines, for instance, based on PP38 gene sequence. So real-time PCR is a very valuable test to confirm the etiology of tumors because it can show that there is a big amount of virus in the samples in the organs with tumors. The difference in the PP38 gene between a field virus and the serotype 1 vaccine like response is very, very tiny. In most cases, is only one nucleotide different between the field virus and the vaccine, and in some cases, even there is no difference. So a very good protocol of investigation and a very good lab is necessary to make sure that we come to the right diagnosis. So PCR test can be performed on tissues and organs like spleen, organs with tumors, and also the feather pulp. And samples can be fresh, can be frozen, or can be prepared on FTA cards when we need to send from the farm to a lab, and we don't have the possibility to let's say, to drive directly in a short time to the lab. So FTA cards can be used because they represent a mean to inactivate the virus and to avoid a risk of contamination by shipping this type of samples. So one point very important is a proper differential diagnosis, because Mareks disease is not the only infection causing neoplastic lesions. We know that also avian leukosis with the different types, you know, A, B, J, etc., reticular endotheliosis, they can cause neoplastic lesions in chickens. And also there are non-infectious tumors. So there are sporadic cases with presence of tumors in chickens with not caused by viruses. And there is another condition. Let me say that today avian leukosis and reticular endotheliosis are extremely rare. They almost disappear from poultry production, except from very few cases. For instance, reticular endotheliosis is reported in China from time to time. But in the rest of the world, it is absolutely unlikely at the moment nowadays to have cases of REV or leukosis infections. There is in commercial pullets another condition called peripheral neuropathy, which can resemble Mareks disease in young pullets. I will talk about it in a minute. And there are also other conditions that can cause nervous signs and paralysis, like Newcastle disease, vitamin B2 deficiency, botulinum, etc. So we need to keep into consideration also these specific signs. And other conditions causing cachexia, stunting, depression, dehydration, sometimes they are confused with the cases of Mareks disease. So a thorough visit and evaluation is necessary by the vet or by the poultry specialist on farm. Peripheral neuropathy is seen in commercial pullets starting at 3-4 weeks of age and up to maximum 10 or 12 weeks. So it occurs in young pullets. It doesn't show visceral lymphomas, so there are no tumors in these pullets. There are only inflammatory lesions in the nerves. and usually there is no presence of the Mareks virus in lesions. But the only similarity is that we have the same type of inflammatory lesions as with some cases of Mareks. And so pullets, they have lameness, they cannot walk, they have a spastic paralysis, they cannot drink and eat, so they need to be culled because they will not grow. And a few years ago, we did a publication together with Isabel Jimeno on several cases of peripheral neuropathy which occurred in Europe. These cases were confused with Marek disease. We clarified by different tests that it was a peripheral neuropathy. Peripheral neuropathy is a kind of autoimmune reaction to the nerve tissue. So it is the immune system of the chicken themselves causing these inflammatory lesions in the nerves. Okay, so and this occurs especially in some genetic lines more susceptible to this condition, especially in combination with intensive vaccination program with certain serotype 1 vaccines. This condition is mono or bilateral. It is irreversible, so it will lead to culling of the pullets affected. So if we would like to have a broad, how to say, approach and complete practical protocol for diagnosis, we have 3 different steps. One is in the hands of the farm field veterinarian. The field veterinarian is or the poultry specialist in the farm is the one visiting the flocks, collecting samples, and based on lesions and signs, taking samples to send them to a pathologist or to a virologist in their labs. So the veterinarian on farm can come to a suspicion of Mareks disease based on lesions and signs, but the pathologist and or the virologist will confirm this based on histopathology, based on lesions in the case of the pathologist, or based on PCR test or isolation of the virus in the case of the virologist, and detection of the virus and defining the amount of virus by real-time PCR based on a CT value. Okay, and of course the virologist and the pathologist will help to make sure that Mareks disease is not confused with vertical endotheliosis, leukosis, or other conditions. I want to stress one point. If we detect an oncogenic Mareks virus from one chicken or from a group, a flock of chicken, this detection alone without other signs is not sufficient to make a confirmatory diagnosis of Mareks disease. Because we know that the virus can be present and latent in chickens without causing a disease. Only when this detection is associated with the clinical signs and typical lesions, this will lead to a diagnosis or to a very likely diagnosis of Mareks disease. On the other hand, if we make a diagnosis of Mareks disease in one or very few birds among a flock with many thousands of chickens, this does not imply that the majority of the current flock mortality is caused by Mareks. So a typical outbreak of Mareks disease is when we detect the virus, we see the lesions, we see the signs, and the majority of the mortality is caused by Mareks virus. Okay? So to control Mareks disease, there are different strategies. And for sure, hygienic measures and biosecurity programs are absolutely essential to prevent or at least to delay the challenge. We know that the later is the challenge, the lower are the probability to face Marek's disease problem, because if we give time to the vaccination program to develop a good immune response, this will be capable to block the infection, or at least to prevent the infection to cause a typical disease. So if we in a farm, or if in a production unit, we apply a thorough cleaning and disinfection program, we apply a proper downtime period between one cycle and the next, we avoid a strong challenge during the first days or the first weeks of the life of a chicken flock. If we keep older flocks isolated or not, related, functionally correlated with the younger chickens, if we dedicate staff exclusively to each new flock without mixing staff working in older flocks with the one in younger flocks, we have a good chance to control this infection, of course, with the help of a vaccination. So vaccination, the purpose of vaccination is to increase the resistance of birds to the infection. And the vaccination itself, as a measure, is key for Marek's disease control, especially if we give time to the vaccine to develop, to induce development of herd immunity in the first days or weeks. So cleaning, disinfection, preventing early challenge, vaccinating properly chickens to make sure that they have a strong immune response before they face a field challenge. So vaccines and vaccinations are critical to control this infection that, as it was explained, is known since more than 100 years and probably will stay with chickens for a long time. The Marek's vaccines were the first example of a vaccine capable to control tumors. I mean, in all types of medicine, human or animal medicine, this is the first example of anti-tumor vaccine. And it was also the first example of in novo vaccine, so vaccine administered during the incubation phase, usually between 18 and 19 days of incubation. Another typical features of Marek's vaccine is the early onset of protection. This is also critical because if we provide the strong protection in a few days or within 1-2 weeks, in case of an early challenge, the immune system will be able to control the infection. They are nowadays all deep frozen cell-associated viruses, this type of vaccine, so they need to be stored in liquid nitrogen to guarantee the livability of the cells containing the virus of the vaccine. And what they do is to provide a long protection, a lifelong protection against tumors just after one shot. And we will see which vaccines, but at the end of the day, one shot can be enough to protect chickens, for even long-living chickens, for life. If we manage properly vaccines and vaccination, they are not affected significantly by maternal-derived antibodies, and this is important to avoid this effect, because maternal antibodies could interfere with the vaccine if the vaccine was not protected inside the cells. But we have also to know that Marek's vaccines do not protect completely against Marek's infection, against Marek's disease shedding and transmission. So even a flock completely protected from clinical signs and lesions and tumors can still get infected and shed maybe lower amount of virus, but can still shed virus and transmit this virus to other flocks. So the history of vaccines and Marek's vaccines and vaccination is already longer than 50 years, and the first vaccines were HVT and CVI 988, which is commonly called Rispens, and SB1. So we have serotype 3, serotype 1, serotype 2 vaccines. And then later on, especially starting 15 years ago, many different HVT vaccines were introduced in the market as HVT vector vaccines for HVT IBD, HVT ND, HVT ILT, and more recently trivalent vaccines, HVT ND IBD, HVT ND ILT, HVT IBD ILT. But the last, I would say, news, the real new introduction of a Marek's vaccine has been the one based on RN1250 vaccine that was introduced a few years ago, because this is the only serotype 1 vaccine that was developed in the last almost 50 years. So this is the real news for Marek's disease control by vaccination. If we consider the different type of Marek's conventional vaccines, there were three kind of generation of the vaccine. The first generation, the second, and the third. And this generation of vaccines were introduced to start controlling virulent Marek's, and then very virulent, and then very virulent plus. And maybe we need a vaccine for the even more virulent strains that may emerge in the next years. So we had, as we said before, serotype 1 serotype 3 HVT vaccines. We have serotype 2, serotype 3, and with increasing protection provided by this program, and then a combination of the different serotypes. So serotype 3 alone, so HVT alone, HVT in combination with SB1, Rispens alone, Rispens with HVT, or the combination of the three. So different combinations providing increasing protection. But the RN1250 strain and vaccine that was introduced very recently, initially in the US and later on in many other countries in Latin America, in the Middle East, in Asia, and this year also in the European Union. This is based on a virus that has been obtained by combining genes obtained mostly from Rispens. About 84% of the genes of RN1250 are from Rispens, and especially genes like PP38, MEG genes, and all genes that are known or suspected to play a role in virulence and oncogenicity, they come from Rispens, so we are in a very safe situation. But other genes to characterize and increase the efficacy of the vaccine are coming from MD5 strain, which is a very virulent virus, 7.4%, or from RM1, which is it's a virulent Marek's virus, providing 9% of the genes, and also with insertion of long terminal repeats. So it's a kind of chimeric virus that with all different characteristics come from the different donors is providing a very high level of protection to the chickens vaccinated. Of course, from a development point of view, this is a very innovative design. It has nothing to do with any other vaccines available in the market. It induces a very early onset of immunity. There are data showing that even 4 days after vaccination, the protection is complete against very virulent strains. It protects against the most virulent Mareks viruses. And beside this high level of efficacy, it has a very safe profile. So a combination of safety, efficacy alike. In the world, different vaccination programs are applied in different types of chickens and in different countries or different companies. So broilers, some broilers are vaccinated, some broilers are not vaccinated at all. Then some companies, they vaccinate with HVT alone, some they vaccinate with SB1 and HVT. But the most common program for commercial layers and for breeders or parents or grandparents is based on the combination of HVT and response. Although there are also companies using the combination of HVT plus SB1 plus response or response alone. There are also factors affecting vaccination. So it's not only the vaccines themselves, but also the way we handle, we manage the vaccines, the storage, reconstitution, and application of the vaccines. So the dose and the administration route are of course relevant. So the higher the dose and the most precise administration route via in ovo or via subcutaneous or intramuscular are important. Maternal antibodies, as I said, if we manage properly the vaccine, these vaccines can escape from the effect of maternal antibodies. Revaccination is practiced in some companies, so chickens can be vaccinated at the hatchery and maybe revaccinated on farm. The age challenge, so the later is the challenge, the higher is the probability to avoid Mareks outbreaks. The challenge strain, we know there are very virulent plus, and maybe even more virulent strains. So this is also a factor that can influence the outcome of the challenge. Stressing and immunosuppressive conditions, they can decrease the efficiency of the immune system and so the level of protection. And there are also genetic lines with higher or lower level of natural resistance to the infection. And actually, one of the fields of research nowadays is trying to develop genetic lines with a strong natural resistance to Mareks disease, beside vaccination and biosecurity. Of course, with the vaccination, there are some main causes of vaccine failures. One group is depending on the insufficient vaccine dose for different reasons. Another may depend on the early exposures of chickens to the challenge. And the other one is maybe the presence of VV plus or VV plus challenge strains that can overcome the level of immunity achieved with the vaccination. Vaccine preparation is very critical. It is critical from the temperature of the water bath point of view for reconstitution of the vaccine in the glass ampoules before putting in the diluent. And so it is critical the timing for throwing the vaccine. So 60-90 seconds are considered safe for the livability of the vaccine. The temperature of the diluent, we normally suggest to keep a diluent at room temperature for dilution of the vaccine. It is important to rinse the ampoules to collect all the amount of vaccine present in the ampoules, injecting the full dose, so avoiding fractions of the dose, which is done in some companies in some countries. So the full dose is important. The more we cut the dose, the more we decrease the efficacy of the vaccine. The use of additives, for instance, blue dye can be used as a colorant to trace the vaccination and to have a visibility on the application of the vaccine. And there are also other additives, but we have to make sure that the colorant we use is compatible and it is safe for the vaccine. And the administration, once the vaccine is dissolved in the diluent, it has to be injected within 1 or maximum 2 years. But the shorter the timing from reconstitution to vaccination, the better it is. So administration can be done subcut, intramuscularly, or in ovo. Of course, there are different machines, different types of equipment for the different needs. There are semi-automatic injectors, there are small robots, there are more complicated robots like carousels, and there are in ovo machines that can inject tens of thousands of eggs per hour. But anyway, any equipment, and there are also manual syringes. Manual syringes, they work perfectly like other injectors if the staff is well trained and will put the right accuracy for vaccination. But for any injector, it is important the level of hygiene. It has to be clean, disinfected, and maintained and calibrated to inject still sterile vaccine with the right volume, the right dose. And during vaccination, we recommend to squeeze the diluent bags to avoid the sedimentation of the cells in the diluent bag, to avoid having some chicks receiving a bigger dose and some chicks receiving a smaller dose of the vaccine, because the potency, the efficacy of the vaccine is based on the number of cells that we inject to each individual chick. So to avoid vaccine failures, it is recommended to monitor the level of liquid nitrogen in the D-walls, in the containers, to guarantee that the temperature inside is suitable to preserve the livability of the cells and the vaccines, and also check the number of plaque-forming unit injected per chicken. And it is important, as we said, the preparation of the vaccine reconstitution as indicated by the manufacturer of the vaccines, and to make sure that we inject the right dose for each bird. Use of the dye, as we said, to trace the injection of the vaccine. Avoid using antimicrobials that can impact the livability of the cells. We know that the majority of antibiotics will reduce the titer of the vaccine in a short time. So we recommend not to use antimicrobials mixed together with Marek vaccines, or if this is not possible, to use only antimicrobials which are tested to be safe for Marek vaccines. And of course, you know, if we apply effective hygiene protocols, this may allow to avoid using antimicrobials. The other point is to avoid early exposure, because the early exposure will put in danger chicks because they don't develop yet, they didn't develop yet the immune response to the vaccination. And you know, using a PCR test is an option to quantify the amount of Marek virus still present in a house before or after the hygiene procedures, cleaning, washing, and disinfection, taking dust samples or taking any kind of samples and swabs from the house where we want to place the new flocks. Okay, so here is a picture taken from a breeder house after cleaning and disinfection, where they are going to take samples from the fans, from any type of surface, and measure the amount of virus remaining in the house before placing chicks. So the dust is a good sample, swabs, etc., with a lab with the capability to measure this amount of virus. So in conclusion, we know that Mareks virus is continuously evolving. So there is a high risk to face more virulent strains in the next years. We need to monitor and to know what is going on in the field with the virus. It represents a permanent challenge in chicken farms because this virus is considered to be almost ubiquitous. So the virus is in the chicken farms. And on the other hand, we are developing rapidly new diagnostic techniques, more sophisticated, more precise, more accurate. And also, there is a possibility to design a new generation Mareks vaccines, like I was describing the RN1-50 vaccine, with more chance of controlling more virulent strains. And also the vaccination technology with the new types of equipment is important to optimize the vaccination process and the quality of the application. With this, shukran gazira, thank you very much. And I'm ready for questions after the Arabic summary of my presentation.
السلام عليكم ورحمة الله. شكرا دكتور فرانشيسكو. شكرا جزيلا للسادة الحضور وللزملاء في الوزارة بتنظيم الويبينار ده. أنا سريعا، أنا عارف أغلب المعلومات كانت واضحة، بس سريعا هلخص بالعربي اللي تم. اتكلمنا على حاجتين. أول حاجة تشخيص المرض الماركس، الأعراض والفحص النسيجي، والكشف عن الفيروس نفسه. الأعراض الظاهرية والصفة التشريحية بتبقى في البداية كلها من آثار التثبيط المناعي لضمور الأعضاء الليمفاوية زي البرسا والثايمس زي ما هو عرض. ده في المرحلة الأولى. ممكن في مرحلة متأخرة شوية في اللحم بالتحديد اللي هو بيطول في العمر شوية عندنا، يحصل ضغط على الأوردة اللي في الدماغ، يعمل حاجة اسمها شلل مؤقت أو ترانزيت باراليسيس. لكن أكثر الأعراض بقى اللي هي بتسبب مشاكل اقتصادية هي الأعراض الناتجة عن نشوء أورام في الأعضاء الداخلية والأعصاب، فدي بتعمل تأخر في الوزن، شحوب، انخفاض في الحيوية. بعدين ممكن تشوف كمان الشلل التشنجي أو سباستيك باراليسيس اللي بيعمل أعراض زي الكساح، والنافق اللي بيرتفع بعد كده من الأعضاء اللي هي فيها أورام، أو إعدامات مسلخ في نتيجة الأورام اللي في الجلد في اللحم. من الحاجات برضو اللي بنشوفها في الهيستوباثولوجي أو الفحص النسيجي حاجة من الاثنين، يا إما تايب A أو الدرجة الأولى من الضرر بالأنسجة، ده بيبقى صورة ورم، يعني الراجل اللي هو الهيستوباثولوجيست بيعرف إن ده ارتشاح من خلايا مناعية كتير ليمفاوية، بيشوفها بالميكروسكوب ويقدرها على إنها تايب A. التايب B برضو وارد في الماركس اللي هو صورة التهاب أعصاب فقط. بالنسبة الكشف عن الفيروس نفسه كأحد وسائل التشخيص، إن أنا سواء العزل الفيروسي ده بيبقى العينات بنجمعها من الدم أو الأنسجة اللي فيها أورام، وبتزرع على سيل كالشر لتكاثرها، وبعدين بيحصل التمييز والتوصيف الدقيق للفيروس أو الكاركترايزيشن، ممكن حاليا بالجين سيكونسينج التسلسل الجيني، او دراسات تحدي اللي هي بتعمل تشالنج ستاديز، يعني بناخد المعزوله دي نختبرها مع لقاحات مختلفه فنعرف اللقاح اللي هو يقدر يمنع ظهور المرض، او الباثوتايبنج، وده بيحتاج هو كما قال دكتور فرانشيسكو ان ده محتاج شويه اماكن متخصصه انها بتعمل العدوى وتقدر الباثوتايب او النمط المرضي، هل هو فيرولنت ضاري ولا شديد الضراوه ولا اكتر كمان في بلس وبلس بلس. الاختبارات الجزيئيه او المولكولار بيولوجي حاليا في منه تطور دائم في الاختبارات، فبنعتمد اساسا على البي سي ار والريال تايم بي سي ار من الانسجه اللي فيها اورام او بصيلات الريش عفوا. في برايمر، لو انا بعمل بي سي ار عادي بيبقى في برايمر لكل سيروتايب. احنا اللي بيسبب المرض هو سيروتايب 1، 2 و 3 مش بيسببوا المرض، بيستخدموا في اللقاحات. فسيروتايب 1 بحتاج بعد ما يطلع ايجابي اعمل تفريق، هو السيروتايب 1 ده فاكسين ولا فيلد فيروس. ده بيتعمل جين سيكونسنج لموضع معين في الجين، بيفرق لي بين السيروتايب 1 فاكسين اللي هو ريسبين ولا سيروتايب 1 فيلد فيروس، وقال ان ده صعب شويه في الاعتماد عليه في المعامل العاديه، المختبرات العاديه، لان دايما الفرق بيبقى في نيوكليوتايد او نيوكليوتيده واحده او اثنين، فصعب تلاقيه. ففي خطوه افضل او خطوه مور براكتيكال بتتعمل حاليا بالكوانتيتيف بي سي ار او البي سي ار الكمي. ليه؟ لان من الطبيعي ان انت تلاقي حاجه من الاثنين. هو قال حاجه معادله جميله جدا، قال العدوى مش معناها مرض، يعني قال ممكن تلاقي انفكشن بس ما فيش ديزيز، وممكن تلاقي ديزيز. فيعني ايه عدوى وما فيش مرض؟ يعني دي هي عدوى كامنه او ليتنت انفكشن، الطائر صحيح، يعني عمليه التلقيح تمت تمام والطائر استفاد منها، فحصل منع لظهور الاورام. لكن الفيروس بيدخل ويطلع من الطائر بكميه اقل، فانا ممكن الاقيه بالبي سي ار بس هتلاقيه بكميه اقل. لكن اما بنعمل كوانتيتيف بي سي ار ويشوف السايكل ثريشولد بتاعنا اللي بيحدد قد ايه الانتيجين الدي ان ايه الانتيجين بتاع الفيروس المارك الاونكوجينيك ده او المسرطن في الورم ده، بنلاقيها اعلى كتير لو في ديزيز، لو في حاله مرضيه بتلاقي الرقم ده كبير. فدايما بيتم مقارنه الرقم اللي هو في كوانتيتيف بي سي ار بين العينات اللي بتتراكم معلوماتها مع المختبر، ويحدد ده كميه تقول ده مرض ولا ده لقاح. differential diagnosis الامراض اللي احنا لازم نستبعدها في الحاله دي، الاورام الناتجه عن فيروسات اخرى زي الافيان ليكوزيس او الريتيكولو اندوثيليوزيس، وهو قال الحاجات دي اندثرت الحمد لله في الخطوط الوراثيه. يعني في مرض تاني بيلتبس كتير الامر علينا فيه اللي هو البريفرال نيوروباثي او الاعتلال الاعصاب الطرفيه، وممكن يكون في شلل ناتج عن امراض اخرى او ضعف او جفاف في الطائر، يعني ديهايدريشن لو غيرت مكانه وتسكن في بطاريات ما شافش يشرب او حاجه زي كده. بنعرف لازم نفرق بين الحاله دي والحاله دي. طيب ادى بعد كده دكتور فرانشيسكو بعض الايضاح على البريفرال نيوروباثي او الاعتلال الاعصاب الطرفيه. قال المرض بيحصل في البياض التجاري في عمر مبكر من 4 ل 12 اسبوع. بيتميز نفرقه عن الماركس ان القطيع ده نفسه مش هيعمل بعد كده تطور الى حدوث اورام، هو الموضوع بينتهي على حالات بيحصل فيها التهاب اعصاب وشلل في الاعصاب الرجل بالتحديد. بالهيستوباثولوجي للاسف بيبقى فيه لبس شويه، لان هو بيعمل بي تايب اللي احنا قلنا انه وارد في الماركس، اللي هو البي تايب او الدرجه الثانيه من التهاب الاعصاب. يبقى احنا الفرق الاول ان مفيش اورام لمفاويه حشويه بتحصل. هو طبيعه المرض ده ايه؟ قال ده رد فعل الجهاز المناعي، رد فعل ذاتي للجهاز المناعي بتاع الطائر في بعض الخطوط الوراثيه نتيجه كثافه اللقاحات في الفتره الاولى من العمر الطائر. والالتهاب في الاعصاب ده ممكن يبقى جهه واحده او جهتين من الاطراف. طيب هو عمل بعد كده تلخيصه حلو قوي دكتور فرانشيسكو بالتشخيص من ناحيه عمليه. عمل جدول كده، عرض جدول ان في 3 ستيك هولدرز او 3 نقول عليهم ناس يعني او جهات مسؤوله عن التشخيص. اول حاجه الطبيب البيطري، الثاني اللي هو الهيستوباثولوجيست او اللي بيشتغل على مختبر بيشوف بالميكروسكوب الانسجه، والثالث اللي هو الفيرولوجيست او اللي هيعمل بي سي ار. طيب الطبيب البيطري هو اللي بيبدا بيشوف عينات يجمعها للهيستوباثولوجي وكذلك لعزل الفيروس، وبيوصف الحاله كامله بالاعراض والصور والتاريخ المرضي والظروف المصاحبه للحاله دي. الهيستوباثولوجي بياخد نص العينه والنص الثاني بيوديها للبي سي ار. الهيستوباثولوجي هيشوف الاضرار اللي احنا شفناها النسيجيه، والفيرولوجيست اللي في الاخر هيشوف الدي ان ايه بالكوانتيتيف بي سي ار ويستبعد الريتيكولو اندوثيليوزيس والافيان ليكوز. طب ايه التشخيص النهائي؟ بيرجع برضو للطبيب البيطري لسبب معين، ان هو مش معنى ان انا الاقي فيروس مارك مسرطن ان في هنا مشكله مرضيه، لازم يكون في اعراض عشان اقول انا عندي في القطيع ده المرض نفسه، يعني احد اسباب النافع. يعني لو لقينا الماركس في طائر معين او عدد محدود من الطيور، ده ليس بالضروره ان غالبيه الوفيات في القطيع سببها الماركس. اتنقل الجزء الثاني من المحاضره على السيطره على المرض. اهم حاجه احنا بنتكلم على حاجتين في السيطره او الكنترول: الامن الحيوي والتدابير الصحيه، ده علشان ياخر التعرض للفيروس لان الفيروس منتشر جدا. تاني حاجه التحصين. في الامن الحيوي والفصل الزمني بين الدفعات والاهتمام بالفتره الاولى من الايام الاولى من العمر علشان الطائر يكون مناعه، ده شيء مهم جدا، وعزل العماله والابتعاد عن الطيور الاكبر. بالنسبه للقاحات، لقاحات الماركس بتختلف عن بقيه الامراض في بعض الصفات، انها اول لقاح بيشتغل على الورم مش على الفيروس مباشره، يعني هو لازم سباق بين اللقاح وبين الفيروس الحقلي، ان انا اكون خلايا مناعيه هي اللي بتمنع تطور التيومر نفسه الاورام. لقاحات المارك بجميع انواعها بتقبل الحقن في البويض التفريخ، بتبدا مناعه مبكره. حاليا الحفظ بتاعها هي مرتبطه بالخلايا، خلايا معينه، يعني هي الشكل الصيدلي بتاعها بتقدم في امبولز فيها خلايا جواها الفيروس، فلازم تحفظ في الليكويد نيتروجين او النيتروجين السائل عند سالب 196. هي في هنا صفه في كل اللقاحات انها ما بتحميش او ما بتمنعش من العدوى ولا اخراج الفيروس او انتقاله، لان هي بتشتغل على الخلايا السرطانيه، هي اللقاح بيشتغل عليها وليس الفيروس نفسه. بعدين تطرق دكتور فرانشيسكو لتطور اللقاحات بشكل عام. قال هي بدات من الستينات وسبعينات القرن الماضي، يعني من فتره، وتم استخدام الاول عطرات غير ممرضه زي سيروتايب 3 الاتش في تي او سيروتايب 2 الاس بي 1، وبعدين تم عمل استحداث او اكتشاف عطره من السيروتايب 1 اللي هي الممرضه بس بشكل قليل مايلد، اتعمل لها اتنويشن اللي هي الريسبنس. بعد كده في التسعينات اما بدا الفيروس الحقلي يزداد ضراوه، اصبح ان الريسبنس تم تعميمه كاشتراط اساسي في تلقيح جميع الطيور طويله العمر. ولما زادت الضراوه كمان اضطرينا نستخدم سيروتايب 1 ده اللي هو ريسبنس مع الاتش في تي اللي هو سيروتايب 3. بعد سنه 2000 بدا الهندسه الوراثيه انها تشتغل على تعديل الاتش في تي، ان انا احمل عليه انتيجينز او فيروس للوقايه من امراض اخرى، احط جينات ثانيه زي الجمبورو والنيوكاسل الانفلونزا، حاليا في كله على الاتش في تي. لكن اخر تحديث تم في اخر 5 سنين تقريبا ان انا اعمل ازاي تثبيط للسيروتايب 1 بطريقه تحافظ على احداثه للمناعه. فاتعمل بالهندسه الوراثيه تعديل على الريسبنس وعطرات ضاريه وعطرات شديده الضراوه كلها من السيروتايب 1، وتم استحداث عطره اسمها RN 1250 تدي حمايه اعلى ضد العطرات الضاريه شديده الضراوه مع زياده عامل امان ان هي ما ترجعش، لا يحدث استعاده للضراوه او اي طفرات، لان في تثبيت ليها الجينوم جواه تكرار لونج تيرم ريبيتس من ريترو فيروس بتمنع ان هو يكون فيروس حقلي تاني. العوامل المؤثره على نجاح التحصين، في عوامل ترجع لعمليه التلقيح نفسها او اللقاح لازم يكون سليم، متخزن سليم، الجرعه كامله، طريقه الحقن صح. في عوامل ترجع للطائر زي ما عرضوش للاجهاد، لو تعرض لاجهاد مبكر قبل تكوين مناعه، التثبيط المناعي، الامراض المناعيه الاخرى زي التشيكن انيميا والجمبورو، الاستعداد الوراثي، يعني في بعض الخطوط كانت حساسه اكتر للماركس، وهو قال دلوقتي الشركات كلها بتشتغل على انتقاء سلالات مقاومه للماركس بصوره احسن، لان المرض نفسه بيتطور. وثالث عامل اللي هي الظروف الحقليه نفسها، يعني انا العمر عند التعرض ده اخطر شيء، لو التعرض مبكر ممكن يحصل مشكله. والعتره اللي انا متعرض لها في الحقل ترجع برضو هل هي فيرولنت ولا فيري فيرولنت، يعني الضراوه بتاعتها قد ايه، هو ده اللي ممكن يقول يحصل مشكله ولا لا. بعدين تطرق عرض هو صوره للتحضير واستخدام اللقاح. باختصار احنا لازم نحضر ونستخدم لقاحات الماركس وفقا لخطوات وشروط خاصه من الجهه المصنعه يجب الالتزام التام بها لنجاح عمليه التحصين. التوصيات بقى لتجنب فشل التحصين، فيه هو قال 5 نقط، بس طبعا بنرجع كمان للمانيوال بتاع اللقاح نفسه الانسرت. لازم نراقب مستوى النيتروجين السائل في الكونتينر اللي انا مخزن فيه اللقاح، لان ده ممكن ياثر على اللقاح في الانبول قبل التحضير اصلا. وبعدين بعد تحضير اللقاح ممكن يحصل تغير في الفيروس لو انا محضره بطريقه غلط مش زي توصيات الشركه المصنعه. ثالث حاجه لازم نراقب الطيور اللي فاتت من التحصين عن طريق اضافه صبغه معتمده على اللقاح، بنشوف وجود اللقاح موجود ولا لا في مكان الحقن. اهتمام باشتراطات صحيه في المعدات دي نفسها وتعقيمها معدات الحقن، لان انا مش عايز اضطر استخدم مضاد حيوي اخلطه ده عشان يمنع التلوث البكتيري، لان اي مضاد حيوي ممكن ياثر على فتره صلاحيه لقاح المارك نفسه. فده رقم واحد، ان احنا بنحافظ على الهيجين في الفقاسه وفي الاكويبمنت اللي معايا. تجنب التعرض المبكر للفيروس الحقلي، وتقييم كفاءه التطهير بعد ما اخلص تطهير، والامن الحيوي، وقال انا ممكن اخد عينات من الغبار وعند المراوح اقيم الوضع عندي. باختصار اهم الاستنتاجات اللي قالها: تطور الفيروس الحقلي مستمر عبر السنين، في تحدي من الفيروس الماركس دائما لجميع مزارع الدواجن في كل انحاء العالم، في تطورات مواكبه بتحاول تواكب في عمليه التشخيص حاليا، تم استحداث جيل جديد من لقاحات الماركس زي العترة اللي هي RN 1250، وفي دايما تطور في معدات واجهزه الحقن علشان ضبط عمليه الحقن. شكرا جزيلا. وحاليا انا هيبقى معانا دكتور باري فليمنج علشان الاسئله والاجابه هينقلها للساده السبيكرز والساده الحضور. دكتور باري please you can take the question and answers.
شكرا. Right, there's been quite a few excellent questions, so we will do our best to get through them as best we can. So the first question that has been fielded to our speakers is: how can we check the plaque forming units of Marek disease vaccines?
I don't know, should I answer, or maybe Stefan, Dr. Stefan Lemière?
Okay. Okay, I'm not sure about the question. Is is it really the SOP to share or some of the guidance on the principle? I'm not going to speak about that one. Again, you know, this is a titration method. This is related to some of the virus activity in cell cultures. Again, titration. Again, the objective in the PFU check is quite important for vaccine development first, and later on, I think it's also important to tackle, I would say, the virulence or the increase in virulence of the Mareks we've seen. Let me comment on that one. That will be, I would say, more appropriate for the audience. You know that if we refer to response, you know, the PFU per dose have been increasing during the last decades. In fact, we started producing response vaccines something like around 1,000 PFUs. And it was a standard. It was really considered at, say, when the products were developed back to the years 1980s, as really considered best in class titer that was really needed for control of any of the Marek virus challenges in the field. And little by little, we've seen that there was really an increasing demand for higher PFUs down the road. So that was really also correlated to some of the increase in virulence. So overall, the PFUs, what is that? The first one is an analytical method to make sure that we've got the proper plex seen on your on your check of the virus activity. So this is an analytical method. This is related to the titer and the number of the virus count you have per dose or per ampoule. And later on, what is really important to tell is that it's really related, as long as you refer to all vaccines, related to some of the correlation between increase in virulence and also check on the PFUs. That means for newly introduced vaccines, as Dr. Fondini was showing, I mean, the RM, the thing is, it's a different story because we start with something else. So that's where, again, it's very important to tell you that, again, we've got, let's say, that minimum protected dose that is defined for this purpose vaccine.
And if I may add something, it is important to know that only some lab with a high level of skills, they are capable to perform the PFU test. And even it is sometimes not appropriate to compare PFU results from one lab to the one in another lab, because the different labs and different operators may give some different results. So it's a very, very, to say, delicate issue. You need very good lab, you need very reliable lab to perform the PFU test.
Thank you, gentlemen. That's great. The next question is, can we double dose with a vector vaccine such as HVT-ND at day old?
I think it is possible. What is more, how to say, critical is if you use an HVT-ND with an HVT-IBD or HVT-ILT, whatever. If you use two HVT-ND, you simply double the dose of the vaccine in the same chicken that you vaccinate. So you just increase the dose, and probably the efficacy is also positively affected by this.
Excellent, thank you. The next question is how I can differentiate between peripheral neuropathy syndrome and Marek's at 5 weeks of age in a layer flock.
At 5 weeks, I don't think it is a case of real Marek's disease. Is 99.9% a case of peripheral neuropathy, because Marek's disease usually in pullets doesn't appear. I never seen in my life before 10, 12 weeks of age. But in any case, at 5 weeks, we see that pullets, they only have lesions in the nerves. So they have, and if we have the possibility to perform a histopathology, it will be an inflammatory lesions in the nerves and nothing else. So no tumors, no other lesions typical of Marek's disease. And if we also do PCR test from the nerves with lesions, we will not probably find a significant amount of Marek's virus.
Excellent, thank you. Next question is, what is the best method for detection of Marek's disease, and how do we differentiate between recombinant vaccines and field strain?
Maybe I can comment on that one.
Go ahead.
Yeah. Okay. On the concern of the vaccine take side, and maybe Francesco will please complete. On detection of vaccines after injection is not an easy deal. It's not a new one. As long as you refer to the HVT are rather easy to track with the PCR, and can be also monitored as long as you've got vectored vaccines with specific serologies. That could be the VP2-IBD, for example. So that one, at least on the HVTs, we can vectored vaccines or plain is rather straightforward. For the response in other Marek's vaccine is more complicated. The replication profile in vivo is somehow more complex, and probably is not really the most appropriate way really to monitor. It's not an easy deal. It's not new. It has been investigated in many cases. So this is really mostly for vaccine tech monitoring. And maybe Francesco, you may complete that answer maybe on the diagnostic side.
Yeah, I think today the best method, and also the most simple method, is a PCR test with the different options. As I said before, specific serotype 1 to quantify the amount of virus, and to complete the answer is the recombinant vaccine requires a specific PCR amplifying a portion of the genome which is unique. So it was developed and can be developed a specific PCR to amplify this and to make sure that the virus we detect is neither a response traditional vaccine nor a field virus, although it is serotype 1.
Excellent, thank you. And a further question here is, how do we evaluate the vaccine application of Marek's disease vaccines in parent stock in layers? And is there a better site to vaccinate them, such as intramuscular administration or subcutaneous?
I don't know, should I answer?
As you want on the function.
Yeah, so the vaccines, Marek's vaccines nowadays are mostly applied by subcutaneous injection or by Innovo, but we know that they, especially response or serotype 1 vaccines, in many cases they have been injected by intramuscular application, and they work in either way, either by subcutaneous or by intramuscular injection. So I don't think there are significant, provided that the injection is done accurately. The other part of the question was how to evaluate. Yeah, okay, so there is, how to say, a kind of evaluation that is based on the use of a dye to make visible the site of injection and to make sure that the vaccine is injected in the tissues. So there is no drops or droplets of the vaccine on the fluff of the cheeks. So all the vaccine is injected in the tissues, and it can be seen subcutaneously because of the blue. And then after vaccination, there is a possibility to monitor the vaccine take by detecting the vaccine in different types of samples. Ideally, or how to say, the most consistent type of tissues is the spleen, because the vaccine early after application will colonize the spleen and replicate, I would say, massively or very efficiently in the spleen. So usually the most convenient period is between 7 and 10, maximum 15 days after vaccination from the spleen, or for some vaccines also in the feather follicles. After this period, the risk is that we detect either the vaccine and or a field virus if there was an early challenge. And so if your purpose, your objective is only to evaluate the vaccine take, the recommendation is to take samples between 7 and 10 days after vaccination, and the spleen is the best sample.
Okay, thank you.
Thank you, Dr. Barry. Actually, the time is gone, our time until 6 p.m. So we will finish this webinar today, and thanks for all our panelists, Dr. Barry, Dr. Francesco, Dr. Stephanie, and all from Bringer Ingelheim and from Al-Qusaybi company. Thank you for all. and ان شاء الله عشان الوقت بس احنا وقتنا لحد الساعه 6، فشكرا جزيلا لكل الساده الحضور، وان شاء الله يعني نلتقي في ورشات اخرى عن امراض الدواجن، وبرضو يعني الاسئله والاجابات ان شاء الله ممتده على الواتس او على جروب الوزاره او على ايميل الوزاره، يعني ان شاء الله تكون الاجابات توصل لكل الناس يعني. شكرا جزيلا لحضراتكم.
Thank you, Dr. Sami. Thank you so much.
شكرا.
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 شكرا دكتور سامي.
شكرا. شكرا.
شكرا سادة الحضور.
شكرا.